Okay, so in general now, we want to look at the graphs of sine and cosine. So 1, if f of x is equal to a sine bx plus c plus d. We are saying the amplitude is always equal to the modulus of a, meaning that it must always be positive of the a given. The period is 2 pi over b. The phase shift, horizontal, phase shift is going to be, raise a hand, Adnan.
Yes, sir. I've got a question on the period.
Yes.
The 2 pi, does it differ or maybe it's constant? As in maybe sometimes it can be 3 pi, 4 pi, or maybe it's always 2 pi.
For sine and cosine, sec and cosec, it's always 2 pi on top there. What differs now is the b.
Okay, thank you, sir.
Yes. So then horizontal phase shift, it will be, you always solve for x, meaning in this case, we can say x is equal to negative c over b. What I mean is you equate bx plus c to 0 and solve for x. And then the vertical is also a phase shift. This one is directed, it's a d. Okay, so the vertical shift is where you lift the graph up or down, horizontal to the right or to the left. So what happens is that if the number you get here, is positive, you shift to the right. If the number you get here is negative, you shift to the left. When you calculate and you get that x is equal to positive, meaning that your shift is to the right. If it is negative, your shift is to the left. The same thing with d. If d is positive, you shift the graph upwards. If d is negative, you shift it downwards. Okay, so now, if there are two ways here, if you don't use a table, if I don't use a table of values, I can decide to get what we call the scale. The scale is where you get 2 pi, is where you get your period and divide it by 4. Why dividing the period by 4? Because we say that in the normal graph of sine, the shape has this behavior, meaning it has, apart from 0, the starting point, it has the turning point. You can call it point 1. It has the first intercept after 0. You can call it point 2. It has the minimum turning point, 0.3, and it has another intercept, 0.4. Now, these 4 critical points can easily help us if we break the period, because these are strategically put there, meaning we can strategically obtain them. If whatever period you're given, divided by 4, you get these 4 points. For example, when we are dealing with the normal sine x, we say the period here is 2 pi over 1, which is our b, meaning we will have, when we break this by 4, it will give us pi over 2. So we have pi over 2. Then you add pi over, remember we are starting from 0. So 0 plus pi over 2, you get pi over 2. This number you get here, you add it to 0, you add the number you get, you keep adding that number for you to obtain new x values to use in your sketch. So 0 plus pi over 2, we get pi over 2. Pi over 2 plus pi over 2, we'll get pi. Pi plus pi over 2, we'll get 3 pi over 2. And again, 3 pi over 2 plus pi over 2, we'll get 2 pi. You can use even the table now, where you say, okay, what is sine 0? Sine 0 is 0. So you have a point there. The sine 0 is 0, so we have a point here. What is sine pi over 2? Sine pi over 2 is 1. So we have another point there. What is sine pi? Sine pi is 0. So we have another point there. What is sine 3 pi over 2? Sine 270 which is 3 pi over 2 is -1. So we have another point here. And put -1 here. What is sine 2 pi? Sine 2 pi is +1, is 0. So we'll get there. So sine graph is going to come that way. So you've seen how the period divided by 4, which we have called a scale, is helping us to know how far from 0 to the first point. How do we move? Because it becomes a bit tricky. How do I move from 0 to another point? Which point do I pick? Is it 45? Is it 30? Is it 60? Is it 180? Is it 90? So the easiest way of knowing how far from 0 is by dividing a period by 4, and that number you get, you add it to 0, you get your first point. Okay, now these properties here, they come back even if it was cos there. Even if we had cos, we'll still have the amplitude, the period, the horizontal phase shift, the vertical phase shift, and the scale in the same way, even if we had cos. So that will be our second. Okay, so now this can now help us to look at how we sketch the first one. Now the question was demanding that we should sketch both curves on the same axis. Okay, so let's get to sketch a second one. So now I'll start with the second one since we already did the first one. So y is equal to half plus cos 2x. So what is our period? Our period is 2 pi over 2, which is our b. So we get pi. So pi now is our period. So we know that the scale will be pi over 4. So it's no longer pi over 2 now because I'm dividing the period by 4. So it is pi over 4. And then the vertical shift is half. Horizontal shift is 0. So we can sketch this guy here. Emmanuel.
Sir, I'm lost. Which tutorial sheet are we solving? It's like questions are different with my tutorial sheet. I don't know.
Throw sheet 7, question 7. Y is equal
The
to
questions
0.
are different.
How many questions does the throw sheet have?
Like he in my throw sheet, question A is saying y is sketch the graph of y is equal to negative cos x. By 3 sin x.
I'm using the one written in August 2007.
Ah,
So why not? You are applying what we are doing to your throw sheets. Okay, so we'll start from 0 and then go to pi over 4. Then add pi over 4 to the next number. So we'll have 2 pi over 4, then 3 pi over 4, and then pi, which is 4 pi over 4. So what is the period? Okay. So the middle part, the 2 pi over 4, is the same as pi over 2. This guy is the same as pi over 2. So if we went to the left, it would have been negative pi over 4, and then negative pi over 2. Same.
Excuse me, sir.
Hello.
Excuse me, sir.
Yeah, excused.
I don't understand how you are getting the 0. I don't understand the scale.
So 0 is on the x-axis, is on the middle. 0, 0, the middle point of the x or y plane. And then we know that after we get this, look, since we have said that our scale will help us know how we should move from 0. Okay, meaning 0 is a starting point. Now, how do we move from 0? You get the scale and add it to 0 to get your first number here. Remember that the scale takes care of the period because it's dividing the period. So what we've done here is that our period is pi. So we divided the pi by 4 to get pi over 4, meaning from 0, we go to pi over 4. Then we add pi over 4, we go to pi over 2. You keep adding until you get to the period. So now, we are mindful of the question. The question says we must sketch for values of x that are between negative pi over 2 and pi over 2. So cos 0. So now y is equal to, what is cos 0? So we have that plus cos 2, 0. This is half plus cos 0. Now cos 0 is 1. So we get 3 over 2. So of course we know we have 3 over 2 there because we have found it here. So 0, 3 over 2. Get back, y is equal to half plus cos 2. We are now dealing with pi over 4. This will be half plus cos pi over 2. Now what is cos pi over 2? That is cos 90, which is 0. Cos 90 is 0, so we get half. So meaning we have another point, half, and it's made by pi over 4, half. Then we go to the actual 90, y is equal to half plus cos 2 pi over 2. This is half plus cos pi. Now cos pi is negative 1, so we get half minus 1, which is negative half. So we have another point, negative half, 90, so it will be there. Okay. Remember that if you are graphing cos and it is positive the way it is, this guy comes here. It makes something like a bracket, like a quadratic kind. It looks like a straight line. It's just hard to sketch.
Sir,
Hello.
I'm behind now. You are getting 3/2.5. Those like the vertical shift, 3/2.5. How are you going about it?
So we get 0 and substitute where there is x.
Okay.
And then 2 times 0 is 0.
Yes, sir.
Then cos 0 is 1.
Okay.
Then we add to get 3/2.
Yes, sir.
So the same at pi/4, we get half. At pi/2, we get negative half.
Okay. 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 All right, sir. So which points do you have to pick? Like here we picked 0. Here
Then
we
you
picked
pick
pi/4.
pi/4, then you pick pi/2.
Okay. Okay.
So the
Thank
points we
you,
are picking were, if I state by the scale, it helps us know which points are important.
sir. How is the scale? How is the scale?
The scale is the period divided by 4.
Okay. Okay. Okay, sir. Thank you.
All right. So that if you go to the left, to the same story. So to the left, where there is that guy, you get that guy. And then you get this one. And then sketch. So it will be a graph of this nature. So this will be a graph for cos shifted that way. Then we also found the other one that we sketched at first, which was y is equal to half minus sin x. Remember how it came out? We had all the properties. So we said the period was equal to 2 pi. So it had different properties. The period was 2 pi. Okay, but it's okay. We just want from pi/2 to pi/2. Then the scale, it was 2 pi/4, which is pi/2. So for it was just dealing with 3 points: 0, pi/2, and negative pi/2. And then that the vertical shift of half also, like this one. So then we can sketch it. So what we'll do is we just get the critical point. So we'll say half minus sine 0. This will give us half straight away. So we have a point here. Then we also had y is equal to half minus sine. We're now getting pi/2. That is half minus sine pi/2, which is a 90. That's negative. That's 1. So we get half minus 1, which is negative half. So we have negative half. We have a point here. And then when it is negative half, sine negative half. You guys, if you remember very well, we discussed that sine negative x is the same as negative sine x. So when the negative comes out, we'll have plus sine 90. But that is just 1, giving us 3/2. So we have a point that side. And so how is the graph coming out? The graph is coming out, is it this one? It's just difficult to sketch. Something like that. So we'll have 2 graphs of that nature. I think the right sketch should not look like this. It should look like this. where this guy goes something like this. It hits there, and then the other one will be shaping like up. Supposed to, it's just difficult. We're supposed to curve like this and then curve like that. No, it's crucial. I can't do it properly. And even me here, and I'm marking, I'm very near to the way you draw. You find where it's supposed to be a curve, you put straight lines. I might be correct. Okay. Then another question is saying that obtain the points, obtain these points where the guys are equal. So of course, the first one is already obtained. They are equal at x. So anyway, we can't use the graph. If you want, you can just use the initial equations given. So I'm using half plus cos 2x is equal to half minus sin x, so that the halves can go, so that we remain solving cos 2x is equal to negative sin x. Now, because we have cos 2x, we change it into cos squared x minus sin squared x, which is equal to negative sin x. Remember the properties we are using here, cos squared x plus sin squared x is equal to 1. So use that property to change this guy. And it was giving us, I used this one, x plus x to expand, which is coming from a plus b. Okay, so that we change now cos. This is where now we need this one. 1 minus sine, so we'll have 2 of them is equal to negative sin x. Hello.
How did it change to cos squared x and sin squared x?
Okay. Since we said that cos A plus B is equal to cos A cos B minus sin A sin B, it must be true that cos x plus x should be equal to cos x minus sin x sin x. But sin x is just sin squared x. Cos x is just cos squared x. So that's why it changed that way. And then what we have now is 1 minus 2 sin squared x is equal to negative sin x. So we take this guy the other side, we'll get this plus sin x plus 1 is equal to 0. At this point, you let p to be your sin x, so that when you get back there, you get negative 2p squared plus p plus 1 is equal to 0. And so the product, the product is negative 2 and the sum is 1. So the factors will be what? The factors will be positive 2 and negative 1. So we have negative 2p squared plus 2p minus p plus 1 is equal to 0. So 2p, then negative p plus 1, and plus 1, then negative p plus 1 is 0. So negative p plus 1, and then 2p plus 1 is equal to 0. So p is equal to 1, and p is equal to negative half. But what is p? P is sin x. So this guy is 1, or sin x is negative half. Then find the values of x that gives us 1. So of course we know that x is equal to 90, meaning that we have found this one here. And then the other one x is equal to the second quadrant. When in the third quadrant, where sign is negative. So forget about the negative first. Do the sign half. You know it's 30, but 30 it will be positive. 150 to be positive. So we go to the third or fourth quadrant. So what will be that now? So in the fourth quadrant, where the angles are negative, so in the fourth quadrant now, between 0 and 90. So we'll get 360 minus 30. This guy will give us 330. Then minus 360. Minus 360, which will be negative 30. So this is what we want here. So we are meeting at negative pi over 6. So x is negative pi over 6, and x is pi over 2. So I hope you have seen how the subtraction has happened. Remember we said if the theta given is less than 0, you add 360. If the theta given is greater than 360, you subtract 360 until you come down. Now, if you're looking for that negative, then you know it's not to add but to subtract. So to go to the negative. Unless you have questions, otherwise we are done with question 7 now. And we spent so much time talking about the real properties of the graph of sine and cosine. If you understand this, then it becomes easy for you now to sketch. Even if you have a different material sheet, you can still sketch those questions that says sketch sine, sketch cos. Right, question 8. The first one is a bonus. From 0 to 360, sketch y is equal to negative cos x. Y is equal to negative cos x. This one is a bonus because already we know the period is what? 2 pi over 1. The vertical shift is 0. Horizontal shift is 0. The amplitude is absolute value of negative 1, which is 1. So the period is 2 pi. So the scale is 2 pi over 4, which is pi over 2. So we have 0, 90, 180, 270, 360. And then 1, negative 1. So y is equal to negative cos 0. That will be negative 1. So we have a point here. We go again. Y is equal to negative cos 90. That is negative 0, which is 0. So a point there. We go again. Y is equal to negative cos 180. That is negative. What is cos 180? Negative 1. So we get 1. So you have a point there. Then y is equal to negative cos 270. What is cos 270? The guy is negative 0. So we just get 0. So we get back there. And then y is equal to negative cos 360. But cos 360 is 1. So we get negative 1. So the guy comes down. And then we sketch. So this will be the sketch. It's hard to sketch, it seems. Okay, so that is our graph. Y is equal to negative cos x. So that you guys can sketch 2, 3, 4. Of question 8. Remember, you guys, I told you that these videos, if you miss class, every time you miss class and you know there was class, if you don't get the link for the video in the group, you follow it up to this YouTube feed. You find there are so many there. So, and even those who are good at studying ahead, you still find that most of the things that we are doing now, some of them are done, and then just come here to discuss them. So please, if you visit that site, don't forget to subscribe so that you become my good friend. So
I'm going to do.
okay. So remaining 5 minutes. If you have questions, you can ask. We haven't finished the tutorial, so we're still coming back for another session. Hope you're not the ones cooking, ladies. Those who are home.
I have a question.
Please ask.
Yes, I'm just behind where you said when it's negative and when it's positive, you add or you subtract 360 on the angle. Kindly clarify.
The question is here. So yesterday, it's on Friday, we agreed that if the angle you're dealing with is negative, for example, we had negative 194, and the question was demanding that we must give our solution to the positive angles. So we said, we get the coterminal angles. The coterminal angle of a negative angle is gotten by adding 360. If this negative angle is too small, that is even beyond negative 360, we'll keep adding 360 until we come to the positive ones. For example, if it's negative 481, we'll add 360, we'll still get a negative answer. We'll add 360 again until you get a positive answer, that is between 0 and 360. If the number given is 481, bigger than 360, and the question forces us to come back between 0 and 360, then we'll subtract 360 so that we get here. We get the 360, 0 to 360. But in a case where we have a question which needs a negative number, okay, like a sketch here, you need us to find this value here. Now you can do this one. Somewhere here. That value there, which is negative. Meaning, because it's between 0 and negative pi over 2. So in the fourth quadrant, we are going in reverse. So it's like, starting from here, you go to negative 90, negative 180, negative 270, negative 360. When they are negatives. When they are positives, we say 0, 90, 180, 270, 360. That's the reason why we had to subtract in that way. If the number given is positive and is 185, nothing. You present it as your answer. We're only concerned with those that are beyond 360 and less than 0. The ones where we have to formulate as in what must be done. Okay. So nice that you're all quiet. No questions. Okay, so we can log out and come back, guys. Don't get tired. We need to finish the theory sheet. So let's have one more session, maybe we'll finish it.
Okay, sir.
Okay.